Honey, you do me wrong, but still I'm crazy about you. Stay away too long and I can't.
And welcome to the concepts video on dot product and angle between two vectors. Okay, so first of all, we have to define what is the dot product. So dot product, it's basically an operation that you use between two vectors. So let's say you have a v vector and it's given by coordinates a, b, c, and a w vector which has d, e, f as its components. Okay? So we have something like that, two vectors, and the dot product, when you dot two vectors, this is what happens to it. So this is basically saying that you have your A, B, C in for the V, and then you dot it with D, E, F. Okay? And what you do here, the dot product, this function, or this operation, it basically takes the corresponding components, so the x components, it multiplies them together, so A times D, and then we're going to add it to the product of the y components. So that would be b times e, and finally add on the z components multiplied together, so that would be c times f. Okay, so as you can see, the dot product, we take in two vector quantities, two vectors, right? We dot them together and we get out something that looks like this, and this is actually going to be a scalar. Okay, so some number we're going to get as an answer after we do the dot product. Okay, so some properties of the dot product are the following. It has three important ones. So the first one is called commutativity. Commutativity. And that's basically just saying that if you do v dot w, that's going to be the same thing as if you were to do w dot v. So commutativity just means you're able to move them, or move the quantities around, or the vectors, or whatever you plug in, and you'll get the same answer. Okay, so that's the first one. The second is that the following: if you dot a vector with itself, so if we do v dot v, that's the same thing as it's going to come out as a times a for the first component plus b times b plus c times c, right? If you multiply all the corresponding components and then add them together, which this actually turns out to be the square of the magnitude of v. Remember? Because if you were to square root the right side, then you would have a square root on this, in this middle here. So if we were to square root that, then we get that, right? And that would just be the magnitude is the square root. But anyways, okay, so we have this relation here that the dot product of a vector with itself is equal to the magnitude of that vector squared. Okay, so that's an important one that we might use later on. And we actually, I lied, we have four properties. So the third one is, it involves the scalar multiplication. So basically if you stick a lambda in there with v and you dot it with w. So this lambda, again, that's just a scalar, some number that you're multiplying times v. And then so if we have this, then basically what the third property is saying is that you can move this little lambda anywhere and you'll get the same answer. So we can move it right in front of the w, and then we get the same answer. Or you can move it out entirely and do v dot w first, and then multiply it times the scalar. Any one of these are equal to each other. Okay, so the last one, I'll just squish it in here at the bottom, is distributivity. Distributivity. And what that means is that if you have three vectors now, okay, so let's say we throw in a u vector. This isn't a unit one. It's just a normal vector I named u. And then if we dot that with the sum of two other vectors, like this, okay, so let's say you add those together first and then you just dot it. This is another example of vector algebra, okay? Then this u can distribute into each of these, the v and the w, and what you get out instead of multiplying, well, we will be doing a certain type of multiplying, and that is the dot product. So we're going to have u dotted with v. Okay, so that's the first thing you get by doing u times v. And then the addition sign, and then we have u dotted with w. Okay, so it distributes as the u vector distributes to the v and the w via the dot product. Okay, that's the type of multiplication we're doing here with the vectors. Okay, so those are the four properties of the dot product, and now we'll go into how it relates to angle. Okay, so the dot product and angle. So let's get this set up here. Dot product and angle. So let's say our V looks like this. Okay, so here's V and here is W. All right. And they make a certain angle between them. Okay, and usually, typically we take theta to be in between 0 and pi. Okay, so in between 0 and pi. So if we wouldn't take this angle, for example, we'd take the one on the inner part. This is between 0 and 180. Okay, so basically, from the law of cosines, and you might recall that from previous Algebra 2 or trigonometry class, it was really messy. I like the law of sines better personally, but hold on here. I'll put a V there. Okay, so we're going to get this relation, the one that I'm writing down right now. So cosine theta. Okay, so this thing here, this whole thing comes from the law of cosines. And there's a formal proof in your book, which is kind of lengthy, and you might or might not, I don't think it's that important, really, or that essential for the class, but again, it depends on your professor and what he or she requires. But anyway, so here's this relation. This is important, and there are plenty of ways to write it. You can divide by the magnitudes on both sides to get the following. We could have that V dot W over their magnitudes, here we go, is then equal to just cosine theta alone, right? So you could have something like that. Or you could even arc cosine both sides, and what you'd get is that theta, our angle, the angle between these two vectors, is equal to arc cosine or inverse cosine, either one, of V dot W over magnitude of V times magnitude of W on the bottom. Okay, so any of these, if a problem asks you, okay, find the angle between these two vectors, and they actually give you the vectors, you can basically just plug it into this equation here to find the angle. Or if it asks you, what is the cosine of the angle between, then you would use this one. Or depending on what you need, you can use different forms of this equation. Okay. All right, so a little bit more about dot product and angle. So let's say we have this relation or this equation up here. We're starting with this, and based on this here, we can kind of see, like, we can tell some characteristics of what's happening or what's going on between V and W. Okay, so if our theta is equal to pi over 2, which is also the same as 90 degrees, right? So if theta is that, then that means that cosine of that angle, cosine pi over 2, is equal to 0, right? So if the right side equals 0, then that means the left side is going to have to equal 0. So let me show you what I mean. So if we have, I'm going to write this down some more, or again, that's what I meant, again. So if we have that cosine, and our angle happens to be pi over 2, then this is going to make the right side entirely 0. So that's going to be equal to 0. So the left side is going to equal 0. So that means that V, the vector V, is perpendicular, which means that it makes a 90-degree angle, with W, if and only if, this is what that means, if and only if our V dot W is equal to 0. Okay, and again, this sign here, this means perpendicular, and you might also see the word orthogonal. So perpendicular is the same as orthogonal. You might see that. So if a question asks you to check, are these two vectors orthogonal to each other, you would just take their dot product, and if it equals 0, then you would say yes, and if it doesn't equal 0, then you'd say no. Okay, and again, more about angle. Let's explore if let's say V dot W, what if it turns out to be less than 0, like a negative number, right? Then that means that the right side, so if the left side is negative, that means the right side has to be negative due to this equation up here, right? So if that's less than 0, then that means that magnitude of V times magnitude of W times cosine theta has to be less than 0. And the magnitudes, since they are lengths, they're always going to be positive. So we have a positive number here, a positive number here, and this must be a negative number. So that means that our cosine theta is negative. So that means that our angle must be obtuse. Okay, and obtuse meaning between 90 and 180 degrees, or between pi over 2 and pi. Okay, because then that means cosine goes over into the negative side. All right, and then finally, as for angle, what if our dot product between the two vectors is greater than 0? That means it's positive, right? And again, we have that magnitude of v times magnitude of w times cosine theta is now greater than 0. And again, these both have to be positive because they're lengths. And that also means that cosine theta is forced to be positive. So that means it's on the right side of the unit circle, or in the first quadrant, right? The first quarter there. So that means that our theta is acute. Okay, and that implies that it is between, sorry if I'm writing kind of tiny down here, it's between 0 and pi over 2. So between 0 and 90 degrees. Okay?
Curious, baby, how curious can be.